points on the coordinate plane. Your distance formula, again, is d equals the square root of x minus x squared plus y minus y squared. On the actual formula, it does say x2 minus x1 and y2 minus y1, but those subscript numbers are really there just to be picky. For example, if you had 3, 4, and 1, 2, and you were finding the distance between those, as long as when you plug in an x, say for instance, if you chose 3 as your first x, then you would need to choose 4 as your first y. So basically, if they are together in a set of parentheses, they need to go in the same location when you plug into the distance formula. If you wanted to go with 1 as your first x, then you would have 1 minus 3 squared plus 2 minus 4 squared. Looking at an example, here on your picture, you have this point at 2, 2, and this point at 6, 5. And so if you wanted to find the distance between the point 2, 2 and the point 6, 5, what you need to do is plug in your x and your y's into your distance formula. So you would find the square root of 2 minus 6 squared. 2 is an x and 6 is an x. 2 is a y and 5 is a y. Plus 2 minus 5 squared. So you keep going, say 2 minus 6 gives you negative 4 squared. Plus 2 minus 3, which gives you negative 3 squared. Excuse me, 2 minus 5 gives you negative 3 squared. So your negative 4 squared is really negative 4 times negative 4, which would give you positive 16. Negative times a negative is a positive, and 4 times 4 is 16. Negative 3 squared would be the same as negative 3 times negative 3. Negative 3 times negative 3 would give me a positive 9. So 16 plus 9 gives me 25, so I'd have the square root of 25, which would give me 5, because 25 is a perfect square. So the distance between the points 2, 2 and 6, 5 would just be 5. On your first example, it says find the distance between negative 3, 1 and 2, 3. So the first thing you need to know, since it says distance, you need to know the distance formula, which would be x minus x squared plus y minus y squared. The next thing you need to do is label your x's and y's. So remember that a point has an x and a y. The first number that you see is your x. The second number is your y. So when you go to plug it into the formula, it looks like negative 3 minus 2 squared plus 1 minus 3 squared. Negative 3 minus 2 gives you negative 5. And 1 minus 3 gives you negative 2. Negative 5 squared is the same as negative 5 times negative 5, which would give you a positive 25. Negative 2 squared is the same as negative 2 times negative 2, which would give you a positive 4. (25) plus 4 gives you 29, so you've got the square root of 29. On your second example, it says find the distance between negative 2, 1 and 2, 5. Since it says find the distance, you're going to use the distance formula. X minus x squared plus y minus y squared. Label your points x and y, and then you can plug them into the formula. So negative 2 minus 2 squared plus 1 minus 5 squared. Negative 2 minus 2 would give you negative 4, so you'd have negative 4 squared. And 1 minus 5 also gives you negative 4, so you'd have negative 4 squared again. Negative 4 squared is as good as negative 4 times negative 4, which gives you positive 16. So since this one's also negative 4 squared, it would also be positive 16. 16 plus 16 gives you square root of 32. The midpoint formula, is going to give you the point that is exactly in the center of a line segment. So we say that the midpoint is equidistant from the endpoints. Equidistant just means the same distance from each endpoint. So your midpoint formula is going to be x plus x over 2, y plus y over 2. Remember, it's midpoint, and so that's a point, which means that it has an x and a y. And so to get your x, you just take your x's and add them together and divide by 2. To get your y's, you do the same thing, add them together and divide by 2. So on this picture, it's kind of easy for us to find out where our midpoint is, but you're not always going to be so lucky. They're not always going to give you a picture. And sometimes even when they do give you a picture, your picture can be drawn off the scale. So if I wanted to find out exactly where that midpoint was and I didn't want to rely on the picture, I would start out by taking this endpoint, which is at 3, positive 3. Excuse me, that's 2, positive 3. The other endpoint, 2, 3, 4, 5, 6, 7, is at 7, positive 5. I need to know my x's and my y's. Remember, x's are always first, followed by y's. To find out what that midpoint was, I would say 2 plus 7 divided by 2, and 3 plus 5 divided by 2. So take my x's, 2 and 7, add them together, divide by 2. Take my y's, 3 and 5, add them together, and divide by 2. I can keep going. 2 plus 7 gives me 9 divided by 2. And 3 plus 5 gives me 8 divided by 2. 9 over 2 doesn't reduce, but it can be written as 4.5 or 4.5. 8 divided by 2 does reduce, and it reduces down to 4. So the midpoint should be at 4.54. Looking at my picture, I can find out where my M is, where my midpoint is. 1, 2, 3, 4, and looks like a half. And then 1, 2, 3, 4. So my midpoint on my picture did lie at the point 4.54. Like I said before, though, you're not always going to be given the picture. So in example 3, we need to find the midpoint of the line segment with endpoints at negative 3, negative 1, and 7, negative 5. So since it tells me midpoint, I need to remember my midpoint formula, which is just going to be a point, x plus x divided by 2, and y plus y divided by 2. Whenever you have your answer, it's important that you put parentheses and the comma in your answer because, remember, it does represent a point. So your x's and your y's are in your problem. Your first number is your x, second number is your y. So when you go to plug it in, you're going to have negative 3 plus 7 divided by 2, and then negative 1 plus negative 5 divided by 2. Negative 3 plus 7 gives me positive 4 divided by 2, and negative 1 plus negative 5 gives me negative 6 divided by 2. 4 divided by 2 is going to just give me 2, and negative 6 divided by 2 is going to give me negative 3. So the midpoint for a line segment with endpoints at negative 3, negative 1, and 7, negative 5 would be 2, negative 3. On example 4, I'm finding the midpoint of a line segment with endpoints at 6, negative 3, and 4, negative 7. So your midpoint is going to be x plus x divided by 2, y plus y divided by 2. 6 and 4 would be my x's, negative 3 and negative 7 would be my y's. So I'd have 6 plus 4 divided by 2, and then negative 3 plus negative 7 divided by 2. 6 plus 4 gives me 10 divided by 2. Negative 3 plus negative 7 gives me negative 10 divided by 2. I can reduce both of those by saying 10 divided by 2 gives me 5, and negative 10 divided by 2 gives me negative 5. So my midpoint for line segment with the endpoint 6, negative 3, and 4, negative 7 would be 5, negative 5.